Hi, this is my final project presentation. I chose the PhET simulator on charges and fields, so you can look at that afterwards if you so choose. To start off with some definitions, what is charge? An electric charge is a property of an object that causes it to either be attracted to or repelled from another object, depending on that other object's charge. An object can have one of three types of charge, that being a positive charge, a negative charge, or a neutral charge. But in the case of this PhET simulator, and in the case of this project, we're only concerned with positive or negative charges. Neutral charges, you can't use them in the PhET simulator. So they were kind of a non-factor in this, but I saw them in my research, so I thought I would mention it. Two objects of the same charge will repel one another, but two objects with opposing charges will attract one another. So that's kind of like where the whole opposites attract thing kind of comes in. Sorry about that. That's where the whole opposites attract notion comes from. If you had two negative charges per se on the PhET simulator, you can see with the arrows showing direction that they would be opposed to one another. But if you had a negative charge on one side and a positive charge on the other, they would the arrows would indicate that they are attracted to one another. And the unit for charge is a coulomb. I'm pretty sure I'm saying that right. But the PhET simulation deals in nanocoulombs, which are 1/billionth the size, which makes me think it's talking about which makes me think it's dealing with atomic level particles, so extremely small. But that's just a hunch. So that's charge kind of in a nutshell. What is an electric field and what is voltage? I don't know why it keeps going back to the last slide. Sorry about that. There we go. Alright. What is an electric field and what is voltage? An electric field is created by the aforementioned charges and transmits charge between the objects. So charge is necessary to create this electric field because it's the product of multiple charges opposing one another, being attracted to one another. It's kind of like the physical manifestation of these charges. And the field is a physical construct and exerts a force on all objects within it. It also has a direction to it, which didn't exactly play a factor in the PhET simulator, but I thought I would mention that as well. And the strength of an electric field can be determined through its voltage, and voltage, which is also called electric potential difference, refers to the amount the magnitude of an object's energy can change at any given moment. So a higher voltage would indicate a stronger electric field or a more powerful electric field, because there's more of a range in the ways that an object's and that the objects in the field's energy can change, and thus it'd be more volatile. And that's why people say that high voltage areas are dangerous, because they are indeed more extreme than low voltage areas. My question that I postulated, I sought to figure out how the voltage of an electric field would react to two opposing charges moving further away from one another. So what I did, the way I collected data, was that I would I would originally start with 100 centimeters away from each other. I would have one negative charge on one end and one positive charge on the other end, and then measure in the center of the two using the ruler tool. I would measure I don't know why it keeps going back to the last slide. That's bizarre. Oh, I'll just keep talking about my thing, my process. So, yeah, I would place two charges away from each other, and then put the I would measure the volts per meter in the center, and then continuously move the each charge 50 centimeters to the left or right, increasing the distance by 100 meters. I did this 5 times and then recorded my data, and I said on the last slide that I was fairly confident in my hypothesis that the voltage and the strength of the electric field would decrease as these charges got further and further away. And I was indeed correct. As you can see at the beginning, when they're only 100 centimeters away. We're moving all over the place with slides. There we go. I'm not doing that. I don't know why it's happening. But in the beginning, I also found that the intensity of the field decreases more sharply in the beginning, and then as the distance increases further and further, the field decreases slower and slower. So it's kind of an exponential relationship where, like, as soon as the distance starts to increase, the field rapidly decreases, and then the more the distance increases, the less it matters to the field's intensity. So those are my findings. I hope you find them interesting. It was fun to mess around with. Thank you.